Hello, impact users, and welcome to today's webinar. Today, we're going to talk about beam, column, and hollow core elements in Impact Revit. I can see people are joining us, and while everybody's online here, I want to use the time to introduce myself and to introduce the plan for today. My name is Stacy Slava and I'm a part of Impact Revit team in Strusoft. I'm connecting with you from the city of Aalborg in Denmark, and I'm going to be your host for today. This is the first out of three webinars we are doing. It's a continuous story, it's a series. In which one of the webinars we're going to focus on a particular element types. And today we're going to talk about the structural framing elements of beam, column, and hollow cores. Now, what you can expect from today's webinar is that we're going to model with the help of Impact Revit, column, beams, and hollow cores. But not only model, we're also going to go in deep and solve some details. Some examples you can see in here. We can talk about how, with the help of Impact, you can do a beam end details, inserts, such kind of a fixing, recesses. We're going to talk about end details of hollow cores and how, with the several clicks of the mouse, you can insert recess for a bunch of hollow cores out there in your model. We're also going to demonstrate the reinforcement, which I think it's a very, very hot topic within Precast and Revit, and how to reuse a reinforcement that you have drawn in Revit and save it with the help of templates. Use it on all your column and beam families in your model. Once we're done with the modeling, we're going to save the elements. We're going to generate shop drawings. Again, here we're going to use template with the help of a shop drawing template. I'm going to show you how, with a few seconds, you can have the front views, the sections, the schedules that you've set up in your template and get some really presentative precast detailing of a shop drawing. And we're going to see the elements in Project Manager, which is our central tool in the Impact 3D BIM precast system. We're going to view the elements, demonstrate the connection between the Revit design and the Project Manager, and I'm going to give you an ideas of how to continue this precast process. A lot of ideas here, so let's jump into it. I have set up my model. I don't want to use time on setting up. Today we're going to model, we're going to focus on the most important part, the precast detailing. Okay, so here we are in my Revit model. I've connected with the database. I have a Impact Revit project, and I have here in the Impact tab the column, the beam, and the hollow core. The three elements that we are going to talk today, they are placed in the start of the Impact tab. I've also prepared a prototype of reinforcement that I want to use when doing my elements, and it's it's something, it's a sketch that we're going to use for demonstrating how to create those rebar templates and work further with them in Impact. Let's jump into it and start with drawing the columns. The first thing I want to do is, of course, check the level where I am. I'm at level 1. Yes, that's correct. And I have some grid lines. And I'm going to draw the columns that are placed on the outside of my structure. Here I am. And let's see. it's placed up to level 2, which is actually not what I want. It's very important to control that from the start, so you don't need to edit your element. So when you say draw column, the first thing you need to do is, of course, make sure that's a vertical column, and make sure that you have control over your levels. I want to go up to level 3. So I think I'm on my way now. Yeah, you can see on the right what's happening, and Revit has this very good tools for previewing your design. So I think we just can go and use it by dividing the screen. I'm jumping now to grid line C, and as I mentioned in the start, it's just one of a series of webinars. So we've planned to continue the model after today, making a more complex structure in our next webinars coming up in March and April. Okay, we have some columns in place, and here I wanted to notice that while we're drawing, Impact has calculated the weight of the element and inserted a lift, cast in material, a lift that is going to correspond to the geometry and the weight of the element. So it's calculation done in the background, and it's done with the help, of course, of predefined settings by the user in the element definition. I'm going to continue with some columns that are going to be used for my ledge beams. So I'm just going to go in here and insert them. They need to go up to level 2. Okay, the same story here. We have inserted some casting materials and a lifting hole that is used for lifting on the building site. Once we're done with those, we're going to go and draw some beams. And for that, we're going to use the draw beam command. We're going to start with some rectangular beams that I have predefined. And we are on level 3 right now because they need to go up in the structure like this. So all the way up to the level 3, we're going to have some beams in our model. And while I'm drawing the beams, I want to use the time to mention that all these falling menus that we're using today for beam, for column, for hollow core, they are filled with functionalities which each one of them has its story behind its story, its purpose. Um, a lot of them are started actually by users just designing to optimize our standards. We're going to continue here with beams, and we're almost ready with them. Let's see. Yes, it was this one. We missed a bunch of them before we get to the more interesting part, which is the corbels. And what I've prepared today is actually a tool. We have 2 tools for drawing corbels. I've prepared one that I think it's really good to know if you haven't used it before. And it's the one that detects intersection between column and beam and automatically insert corbels. So I think this is something it's really good to know if you haven't used it before. Before we do it, we just need 4 ledge beams in here, and we can jump to the corbel. We're gonna use the section type called ledge beam, and we're gonna draw. Now we need to think. Now we are on a level 3. I think we need to be here because then we don't need to move the element. Yeah, good. So we go to draw a ledge beam. These are going to be the ledge beams on which we're going to place our holocaust later on. Okay, good. Then let me see. Yeah, it looks okay. It's important that we draw them in the correct direction so that we can later on support the holocaust on them. Good. So far, so good. We're ready to jump on the corbels. Now, in order to draw a corbel, we have two functionalities. The first one is insert corbel and a draw corbel. It's described here on the helping text on the right. What is it? But basically, a draw corbel is something I would advise you to use on a single detail solving if you have just a single corbel to draw. But if you are going to draw corbels in a structure like you have in here, so I would say select the structure and let impact detect the intersection between a beam and a column, because then you can say choose it, choose the family, and just insert it. What impact is doing now is just taking the corbels everywhere where we can detect um, intersection between a beam and a column. And now probably you want to have this corbel going all the way from one to another edge of the beam. And for that we have functionality. It's the one in here called full width. So what I'm going to do is just select all of them, select all corbels that I just drawn, and I'm just going to say full width. Okay, and then impact is going to find out which is the host family, and then we're going to make the corbel full width going from one to another part of the column. Okay, so far so good. We have corbels, we have columns and beams in place, but we need to solve a detail in here. You see, our corbel has a socket, and we need a circular recess um, to get to the socket in the corbel. We need to solve this detail. And for that, I would use a functionality called um, beam ends. That's if you select the beam and you go in the following menu, um, you go to this called edit beam command, and here there is a tab called ends. So each element has its edit command, and it's of course adjusted to the um, character of the element. When we have beams, we need to edit probably add angles, we need to add recesses on the left or the right end, or we need to add fixing. So fixing is what we're doing right now, and it's a circular, and you see its dynamic picture here on the right, which is guiding you as a user. It's a symmetric one, and in this case, you need to fill in a parameters ALL1 like this, and I've measured in advance. That's why I know what to fill in here, and I've already can apply this to the right side as well, so that it just comes both on left and right. If I say apply, yeah, it's saying that the weight has changed, and we know that impact detects something happens in the element. So we do a lift checking, And here it is. We actually have some fixing holes on place, and it looks actually quite okay. And yeah, here actually we're going to demonstrate the power of impact because I can just say select all instances again, um, visible in view, and can probably exclude the one that we just made, and use edit beam again. And this time I'm going to do this the same, but for all elements. So this is where you don't need to do it for one at a time. You just go and apply these changes for all elements. We say apply, and the fixing is being inserted on all elements. It's where we have the corbel, and we have solved the detail now because we have a fixing, a circular fixing. Good. Let me see here. We have the corbels and we have the fixing in place. Now it's time to go to one of the most interesting part, and that's the reinforcement. Now, how I usually would do this reinforcement is you're going to draw it with a Revit functionality, and Revit has the perfect tools when drawing reinforcement. Um, but we're going to take it to further to a higher level where we say we don't want to draw this on each column on each element. We want, of course, to save it. Probably it's a typical detail, reinforcement detail for the bottom, for the top. We want to save it with the help of a template, and we want to reuse it. So what you're going to do is you're going to go to the reinforcement tab here in impact and in rebar template. So it's just going to um, go and save a template. If we take a column example, you're just going to say new, we're going to say A6, and then we're going to say N plus A6. That's what I have now. And impact is just going, it's saying that it's not mirrored, that's fine. Impact is going to detect the rebars that you have in there. We say okay, and our template is on place. Okay, and again, you don't need to draw it on each column elements. I can just select them, um, select all instances visible in view, except the one here, and you can apply the rebar templates. You say apply rebar templates, and the one that we just made right now, it's A6. All the rebars are coming on place. So that's where it's saving time for you. It could be, and in this particular rebar, I say I have a combination of shapes. Doesn't need to be throughout the whole element. It could be just part of it. It could be the top, it could be the bottom, the middle part, around a detail. But you can also do a component. You can see here I have a corbel family. So I've done a rebar template out of it. So if I go and select all my corbels in the structure, let's see here, right now I can see I have all my corbels selected. I can say apply rebar, and that's, yeah, impact the test. That's a corbel. I have one of them here, and here it is. I'm going to have a reinforcement for everywhere where I have a corbel in my model. It's family based, right? So um, it's really important to say that if you had same family within the model, but a different type, different dimensions for a type, it will also apply. So it's a family base that can be used within types of the family. Like this one, right? We have We have two types, and the rebar template that I just made and saved in the database can be used for both. And you can have this on a common level. It's sandwich wall, insulated wall, structural framing elements, components like corbel or panel thickening. It's pretty useful. Now we're going to demonstrate how to apply this for a beam, and I have a ledge beam in here, and I'm gonna go and use it for my 4 ledge beams, right? And yeah, here I have um let's see what we have for beam. We have a rectangular beam. This probably it will work. So you can either select all instances, or now when I'm just going to do like this and finish here on the top. Um, I can do some reinforcement. It could be a base for reinforcement you're doing. It could be just, as I said, a detail of it. But it's really powerful tool, which I think you should know about. Let's try this for our columns. And just like that, we just have some reinforcement in my elements. And the last thing I want to mention here before we jump to Holocaust is that um, you can see in here, I have actually some reinforcement added to a component that is to a casting material. And I think it's really, really good to see that this is also something we can do. So if you have a component which has requirements for, in this case, it's lift. So you see every time you use this casting material, for example, lifter, you need to have a rebar around it, one shape, two shapes, whatever. You have actually a possibility to set it up in Impact so that Impact can automatically insert the rebar for you. It's a new functionality that has come in the recent years, and if you don't know it, I think it's good to see how it functions. So you see, here's my family, and it's called 0189 in the Impact database. So what I've done is basically I've gone into 0189 definition of a casting material, and here I've set up in the reinforcement tab, I've set this rebar. So every time I insert this in my model, a rebar is going to appear, and again making your work easier instead of manually adding it each time you use the family. Option that I think it's especially relevant for example, lifters. Okay, good. So we have some reinforcement in place, and on my next webinar, I'm going to talk about reinforcement templates. It's a tool used for walls. So I think here it's a little bit, it's important to differentiate. It's also a very important tool. We use it for walls, but structural framing elements, I think we're more into this tab when we are doing the rebars. And of course, some more functionalities in here, which I think you should give them a chance if you want to explore the reinforcement in Impact for Revit. Now I think we're ready to go and draw some hollow cores, and we're gonna do that here on our ledge beam. So let's jump into it. Um, let's see, we need to plan a little bit how we're gonna draw them. If we draw a section, we go to it. Mm. So here I can see my ledge beams, right? So I need to see how much I want the Holocaust to lay on the ledge beam. So I'll probably go and measure how much we have from top to here. It's 440. And it's good to know that when we place them in the model. They're going to be placed on level 2, I can see. So I go on level 2. And the way I really like drawing hollow cores is actually with the help of model lines. And yeah, it's a pretty much drawing style that I know each designer has, but in that way, I feel I have more control over it. And um, if you use the model lines, you can do as I do later now. On this webinar, I'm just going to select them and draw hollow cores on top of them. So I'm just gonna go here. It takes a little bit more time, but again, it gives you a kind of control over the save. So we'll do it that way now. But of course, impact is pretty often to different ways of drawing it. Um, if you want to draw them, you're gonna go to the hollow core folding menu with all its functionalities, and of course, the first one you're gonna do is say draw hollow core. Here I have some hollow core in my definition. I'm gonna say um, first we need to define the boundary. I'm gonna say pick model lines because I have some model lines on my model. You can also draw rectangular, pick enclosed area, pick points, pick floor. It's a various possibilities here. So I pick the model lines, and impact suggests that it looks like this. You can select the direction by going like on this button. Of course, I would like to have them resting on my ledge beams. Then you can go and choose support length. Here you can go from edge to edge and set a support length. You can go and yeah, try it out. It's a really powerful tool in this webinar. I'm just going to set it to 0. But basically, it gives you possibility to go and define support length for each edge. Okay, so I want just to have it a 0, and we had the 440 of offset. We measure it, and what else? Impact gives you a possibility to insert a partial slab or um, just say that we don't want it. Say I don't want to insert any partial slab. You can just um, yeah untick it. And the strand patterns. In my definition of the hollow core, try to look at the picture here. I have different strand patterns, so you can choose some of them, the ones that suit to your project, and say okay. Okay, so now our hollow cores are being inserted. And yeah, let's take a look at them. Impact is working. Um, let's see how it looks. First, we can go and see how it looks on the section. If I say go to view, yeah, we've actually done pretty well. It's there resting on the ledge beams. But take a look in here. We have some details in the end, right? And if we look at the 3D view, we have some um, we have some recesses, so to call it. And in impact language, we call that in cap. So basically, what you have in here is you can automatically insert geometry on your hollow core. So let's take this one, this hollow core, and go to edit hollow core, right? And here you can yeah, you can go to the InCap tab, and this is the InCap that I've chosen when drawing them. I have several in my database, so this is just an edge without any specific save. can go and see here. I have some parameters that can decide the recesses. Very powerful tool if you know they are repeating geometry within your hollow core floor. Um, yeah, and you can just play with it and see what works for you. Um, what seems good. So we could say okay, and now you can see the shape is changing. We're going back to back to just this rectangular form. I think if we go to the 3D without rebars, you probably see better. See 3D here. Yeah, it gives you a very good picture of how you can just change it. You can also, select, let's say for some reason you wanted to change for, um, all those on this size. So you can just say, again, edit for multiple elements, and you can either select all edges or just one of them. The um, it's up to you basically, and it's just important that you have this, very powerful tool that can just do changes like this in the geometry in a couple of seconds. So this edge right now it's just straight. Okay, and when we talk about the whole course, we have really, really um, interesting tools about that. You can go and explore more in this following menu. The last thing I want to do now is draw the pre-stressed beams on the top, and then I think we're ready to start saving the elements. I'm gonna go into think I'm gonna go into the 3D here and level 3, and drawing pre-stressed beam is just selecting the type, the element type in here, and here I have a pre-stressed beam. So yeah, gonna draw them along the mm, looks good. Looks good. We're gonna see the strands just in a while. And the next step from here, according to the plan, is that once we have them in place, I would like to save the elements and I would like to show them in our project manager. We are in a good time, so we're also going to do some shop drawings. Definitely worth seeing when we talk about the structural framing elements. I'm going to demonstrate now how to do the shop drawing as well for an element, which is again a tool that it's worth giving a try when you work with impact. Okay, we have the pre-stressed beams, and here you can see that we also have the strands uh, in the pre-stressed beams. And I think that now it's time to start saving the elements. You can either do that by selecting an element type at once, or you can just do all of them at once. I say select all instances in visible in view, right? Beside this one, this is my prototype, and say each um, functionality has its saving functionality. Each element has its saving functionality, so probably we can just do like this. We can say can select, cross select. I think that's the easiest way. Let's do it that way. And say save columns. So basically what we're going to do now is that we're going to save the columns in our project. And here it is. Um, we're saving them to the database and all the information about them. Geometry, the components, casting materials, um, reinforcement, it's going to our database. That's what we're doing now. Because once we have saved the element, we can preview it in our central tool, project manager, but we can also make a shop drawing out of it. Okay, so I cross select again and I'm gonna save the beams. So save the beams. Let's see, impact is working right now. Processing 26 beams are detecting, and we start saving them. We have rectangular beams, a sloped I shape, which is the prestressed, and we have some ledge beams on which we rest the Holocaust. Okay, that's the beams, and the last thing we miss is again cross select. You can also select an element by element, but this is the most time consuming. Save Holocaust, right? So we need to save the Holocaust and we say save. And now we are ready after the Holocaust save. Now we're ready to open the project manager. So let's wait 2 seconds more. And we see we're also going to demonstrate now this collaboration between the Impact Revit design and the project manager. Project manager is basically um, previewing information from the database. That's why we need to save the elements in advance. So here is my project. I've opened my project in the project manager and I'm on the model preview and I say reload. Here PM project manager is taking the data out and we can see our detail, precast detail. Yes, here it is, our building. Beautiful. That's what we've did today. And if you press on an element here, um, you can go and see information about it. You see it's a pre-stressed beam, and all this is data that you go and read on the elements. We can go here and see Holocaust. We have columns and beams. Um, Another tip here I want to give you by saving is that I don't know if you noticed, but when we were here on the save, there is a possibility to save an OBC file, which it's a functionality. It's been there for quite a long time, but basically what we do here is that we save a file that gives a very detailed preview of the element. So a very, very good tool to see how the preview now in Project Manager is coming, and you can see the difference. Um, Probably if you go here, um, we go and save. See, this is a column save without WC. This is with WC. So you can imagine all these small components that you have on your element, like casting materials. They're gonna be previewed in here, right? Another tip about saving is that I know some of you are interested in IFC files, and there's come a new setting here. It's a project setting. So if you go into Impact and this, um, you can see export elements to IFC while saving. So while saving the element, the Impact is going to make an IFC file of the element. And later on, you can go and preview it, find it in the project folder, or you can use it when working with Project Manager, which is a powerful tool for designing in I mean, is summarizing a precast process. Later on, you can just take an element and just put it here on the. This is a precast bed that I have. You can just take it and just yeah, just drag it in here. Um, yeah, it's also a tool that has very good control because here it says that I'm messing up with the dates right now, so I don't want to do this. But just to demonstrate that once you have your detail, precast detailing here in Revit, you go and move further with the project. These are some walls drawn in Impact for Revit. You go and use it further where you're going to plan your precast beds. That's some beds for producing the elements, planning the transport, and so on. You can go and also take reports out of it. Everything is now in the database about these details. You can use the full potential of impact. And last but not least, I would like to demonstrate how to do a shop drawing. So once we have it here in Project Manager, which means that we have saved the element. And for doing shop drawings in Revit, we're using this drawing tab, right? So we're just going to go and say create shop drawing and just going to say, okay, we can do for a column and you can choose this one. It's um one. I think a sweet little one there hiding in behind. Let's see how our shop drawing is going to turn out. Impact is working right now. It's what we're doing is based on a shop drawing template that the user has prepared. We are actually creating a sheet, and yeah, we are making a shop drawing. So here is our column, the one that yeah, you can see in here, right? So what I've did is I have this template and I've decided that I want to have a front view, I want to have yeah a 3D view with um, reinforcement. I want to have a section. I probably want to also have some reinforcement with pictures of the shapes and so on, company information, information about the project, everything here. If you've done your template, you can see it comes up within a second. And here you have the shop drawing. From here, you can, yeah, you can go and plot it. Also, we have plotting tools, or we can, yeah, go and preview the shop drawing in Project Manager. You can see here, this is um, this is sheet 13. That's the sheet that we're working on. So if we update here in reload model, we can also see our shop drawing in Project Manager. This is also a good example of the connections that we have between the Revit design and yeah and Project Manager. So here it says we have our shop drawing. Okay, good. I think we'll stop here for today. And as I said before, uh, we are just on the first. That was Precast Detailing Part 1. It's a series we're doing this spring. So you can be really looking forward to the next part, which is the wall and slab. We're going to focus on wall and slab elements, and in April we're finishing with form slab double wall and linked elements, which is a element types that yeah they deserve a webinar on its own. You can go and look more information about Impact Revit on our Impact Wiki page, uh, LinkedIn, and our Truesoft channel in there. It's word following together with YouTube. Otherwise, our webpage is where you can find all the upcoming webinars from Truesoft and sign up. If you have any questions about today's session, you are more than welcome to write to me. I'm pretty happy to come in contact with you and answer your questions if you have any. Otherwise, I say thank you very much for today. It was a pleasure to go with you through structural framing elements and hopefully see you on part 2 in March. Bye for now. Hello, everyone, and welcome to this Impact Revit webinar, Precast Detailing in Impact Part 2 out of 3. Today we're going to focus on two of the most popular precast elements, walls and slabs. I can see people are still joining us, and I'm going to use the time until everybody's ready to introduce myself and the plan for today. I'm connecting with you from Aalborg, Denmark. My name is Slab, and I'm part of Impact Revit team in Strusoft. I'm going to be your host for today and actually for a series of 3 webinars I'm doing this spring, focusing on Impact Revit Precast Detailing. As I told you, we're continuing the series, so we're going to build up on our structure. Last time we did some columns and beams and hull cores, the ones that you can see here. Today we're going to draw sandwich walls on the, so to say, other part of the building on the opposite side. Sandwich walls, solid walls, and slabs. What you can expect today is that we're going to solve some geometries, like I've taken some screenshots so you can just see where we're going with this webinar today. I have some fundamental functionality for you I'm going to present, but for you that have seen Impact Revit before, I've taken some pretty exciting news in reinforcement, which I think is going to be interesting for you to hear. If we start with the news, I'm going to present reinforcement in incaps. That's the technical description of it in Impact. But basically, what is it is how to connect rebars together with incaps with the geometry. So, how to insert this rebars with the help of impact and reinforcement template. We're going to see that. Also, bended mesh. How to make a bended mesh, a mesh out of a rebar, something like this, right? We're going to do that in a sandwich wall. Moreover, we're going to solve details like connecting 3 walls with the help of joint. So, with one click of the mouse, you can insert this kind of ending geometry together with inserting casting materials. And we're going to talk about some pretty easy functionality for you detailing, for you that are detailing slabs. In the end, I'm going to save the elements to the database, preview them on our center tool for the impact database. That would be the project manager, and I'm going to mention some possibilities for integrating Revit, Impact Revit, within the impact system. Okay, but let's jump into it. I think I'm going to go out here of PowerPoint. Here we are. We are in Revit, and as I said, we're going to continue. We had some, this is the project manager where we can preview the saved element right now in this project, right? And we're going to focus on this part of the building, and I'm going to start by drawing sandwich walls. The first thing I want to mention is that the elements we're working on this webinars, the elements that we're working with are in the following menus of walls that you can find here in the impact tab, and slabs are to be found just right next to them. So if you want to draw a wall, you're gonna use the draw wall functionality. And here I'm on level 1 in my Revit model. I'm going to start by drawing a sandwich wall. And here I'm gonna use a functionality that defines um, the definition or chooses the definition that you already have. You can also have already now decide the gap between the walls, but I'm not going to do that now as I'm going to draw a single wall right now. And here it's also important to figure out the geometry of the wall. So 5420. As mentioned, it's not the first time I work with this model, so I have some numbers in my head and written down to get the drawing process faster. I'm going to draw, and I'm going to draw actually from right to left, and a lot of you might wonder why is that, but the simple explanation of it is because of the direction of the wall is the one that is actually deciding which side of the wall is going to be where it's going to be the load bearing panel. So if we go to parts now, we can see that because I draw the wall from right to left, I actually get the load bearing part where I want it. That's on the, so to say, inner side, right? So here on the 3D view, I can see I have some wall, and it looks like this. What I wanted to notice is um, if I do like this, yeah, probably here you can easily see that Impact has also inserted, based on some definition rules, the bracing and the lifts that we have defined in the element definition. So this is happening automatically if you turn on this in Impact, and it's based on calculation of the weight. Okay, I have the wall, but you can see I have a collision that I need to solve. Here's the wall is colliding with one of the corbels. And here I want to show you a functionality which I have a feeling is not that popular also among the established impact users. And it's quite a helpful functionality which I want to demonstrate, and so that you can go and use it in case you are in a situation where you want to use this um, geometry editing. Okay, what you need to do now is to go on the edit wall command. So I'm gonna mark the wall, go to edit wall, and here, there is some in caps, which is basically the deciding the end geometry. We're gonna focus on that just in a while. But this is what I want to show you. That's the other in caps, and it's a pretty powerful tool because if you switch on the wall preview in here, you can actually get a live picture of what you're doing with this. You're basically doing a kind of a recess. I have some numbers here which are going to help me define the recess that I need for the corbel, and you can see it's kind of, you already see it here in the top. So uh, we're adding in cap on the top from left, and you're gonna need the same because there's another corbel on the other side. If I fill in the numbers and press OK, what you're actually getting is the recess. In impact language we call it other in cap, right? But you can see it's pretty easy way to make this end geometry and it's going all the way to the shop drawing and also dimensioning there. It's a pretty powerful tool, other in caps. If you haven't used that before, yeah, go and try it. Also, gable walls, I know people use it for any kind of shape that you don't want to recess. You can actually do it within the wall, editing the wall. Okay, that was the other in caps. I want to move on and draw some walls here on the gable. So I'm going to activate the draw wall command again, and I'm not going to do any gap again because I want to demonstrate the split wall functionality. So I'm going to do a 3000 and I'm going to do the interior again. Okay, so let's see. Yeah, that looks okay. I'm going to draw from top to bottom in order to get the load bearing part on the, so to say, inside of the building. Mm. And here it is. If I press on escape, impact is, um, you can probably see it like this. We have a sandwich wall. It's pretty long one, so you probably want to split it. And here I want to demonstrate the split tool. We have split for vertical and horizontal. We're going to use the vertical now, and first impact says select the walls and press finish, and then you need to select the left reference plane, which in this case is B. Um, Here you can insert the gap between those walls. Let's say we take it as a 16, and pay attention that while doing it, you can actually add an end geometry automatically to this two ends of the wall. So all those in caps that I have in the database, you can go and already use it now. Here it is. I splitted the wall, inserted the gap, and I have my end geometry defined. You can see it in here. Now, why I'm doing that is because usually if you have this particular in cap, you probably want to have a loop, a casting material that is going to be, yeah, connecting those walls. And you can go and use the insert casting material, which is, let me see, which is here, draw casting material command. But I recommend to do it for if you have a single casting material, a place somewhere. But in my case, you're probably gonna have several of them along this wall connection. And here I want to show you a way to insert those loops with a casting material template. So it's one of the ways to use the casting material templates is, for example, in this situation where you have this specific geometry. So you can find the casting material template in the following menu. And what is basically this template doing is that based on some a definition where you have to find the geometry, I've taken a very simple one, um, just to give you the idea of the functionality. But um, you have a geometry, which is my in cap. It's the one here with the place for the loops. I have defined the casting material, and I tell impact how I want this casting material to be placed. So you see here the preview, right? You have some settings saying that it has to be just there. And then you need to also say to impact how to place it. So you say that if it's on left or right, like it is in my situation here, then I want to be 200 from top, 200 from bottom, and 400 millimeters in between those. It's the center of the family, the center of the casting material. There's also different settings here. Um, many ways to do it. But placing left is 200 from top, from the bottom, 400 in between. And here it was again 200 from top, 200 from bottom, and 400 in between. So that was the definition, and I'm going to demonstrate now how it works. What you need to do is you need to say apply custom material template, and you need to select the walls on which it has to be defined, and you need to select the template. So what Impact is doing now, it's scanning. Do you have this in cap? Yes, I have it. I have the one that is 801. And if you do have it, then I'm going to insert the casting materials. 200 from top, 200 from bottom, and 400 in between, as I just said in the I have just set up in the template. So it's a very powerful tool. You can use it for connections. You can use it if you have, let's say, some casting materials along a fastening plate, or um, along the top, along the bottom. A very powerful tool, and I've used it a lot. So I really recommend to explore it and use it in your design. Okay. We talked about the casting material templates, and now I think it's time to do some openings. If you do walls, you can't go without it. You need to do some openings, and we have a draw opening command and edit opening command in the wall folding menu. So if I go, it must be east elevation, this one. If I go on the east elevation, we can draw some openings. Okay, here it is my east elevation, and I still want to see the 3D here on the right. Okay, so one of the reasons why we strongly recommend to use the impact openings, it's because you give a lot of information to the database when using the opening. So it's not only that you here can, you see on the sandwich wall, I have some openings. I would like to draw this door, which is for my type of element, right? You can say that it's mounted in the factory, so you can add the actual kilos of the kilograms of the weight of the door if it says mounted in factory. You can tick this one. You can add a label which is going automatically to the shop drawing when Impact creates it, or you can add this freeze for the ones that haven't worked with them. It's this one, just geometry around it on the surface of the element. Um, yep, I think very popular on agricultural buildings, but not only, of course. Um, so a lot of options here, but if you say okay, what you're actually doing is that you can just add the door, okay? And Impact is asking if you want weight from the element, so it's really good to say okay, and Impact is updating the lift for you. I probably want to do also window. It's the same procedure, say draw opening, and you are doing a sandwich. I have one for here for the window, and I don't want to freeze. I'm just gonna add the window somewhere in here, okay? And update the lifts. So we have two openings. One thing here also, last thing about advantages of doing openings in Impact is that what you can actually do is add some geometry on the left, right, top, and bottom of the opening. So if I go to the definition here, let's see, I go on my main library on the common and I'm going to choose a sandwich. Let's open one. Yeah, you can see in here that is yeah, that must be that is a door. So I have a top edge. I want the top to look like this, the left and the right also like that. So it's a a really good way to also define the geometry of the sides of the opening while drawing it. So that's one of the many reasons why we strongly recommend to use the openings command. Yes, I think now it's time to go to a very interesting topics for, I guess, everyone doing um, precast elements, and that's the reinforcement. I've got two main, um, actually three, right? Three main features that I want to talk about now. The first is the reinforcement template. It's a tool you can't do without if you are working with impact, because it's what it's doing basically is automatically applying. I can show you where it is. It's automatically applying. Um, Let me open it. This automatically applying edge reinforcement, opening reinforcements, I mean stirrups around the windows and mesh in all panels of the wall. That's the first thing. But the one I want to start with is actually the thing I took here at the start, where I told you how to. Um, we have actually added a way to add these stirrups automatically when you have a certain in cap in the wall. Let's say that when you have this in cap, you always have a kind of stirrups. It's something that you tend to repeat in your projects, and you probably want to have it ready so you don't need to redraw it all over again. So basically, how it works is that I have um, I have a wall in here, and if I go on top view, I probably need to go to rebars because then I can also see the rebars. Yeah, here. If I just rotate it so you can better see, and need to go to parts. Yeah. So I have a sandwich wall and I have this stirrup that we've seen in the PowerPoint, right? So what if I want to add it along my geometry? First of all, you need to define that in the in cap. So here is my in caps, and I've taken example with this 807. So let's take a look at it. An in cap consists of, yeah, the geometry that you send to the database to Revit, right? So that's my three layers. Um, Detail that is, notice, automatically added to the shop drawing when you create it to the production drawing. And the new thing here is that you can add this stirrup according to the insertion point, which is the lower left corner. And when this stirrup is added to the in cap, you can go in the reinforcement template. This is where we connect those two, reinforcement template and in cap, right? You can go to reinforcement template. Now it's a sandwich we're talking about. And you can say that if I have an edge reinforcement, you can go here on the setting in cap reinforcement. So if you have this in cap um, added to one of the edges, let's say left or right, you add a stirrup defined in the in cap 200 with 200 millimeter of distance. And let's see how it works. You probably want to see it in this way. Let's see. We're gonna go like this, and I think we can do it directly in 3D view. So first of all, I need to take the in caps for this wall. So I go to edit wall, and I need to see, if you remember, we've added an end cap here around the roof. So on the left side, I'm gonna need this 807 that was just reviewed. Okay, it's just defining the geometry, pretty basic end cap. We keep it simple right now. Okay, so this wall has an end cap 807 in here. So what I expect is that when I insert my reinforcement template, so I'm going to say apply reinforcement template, and I choose this one, say okay, and I choose the wall. I'm not only inserting the mesh, the edge rebars if I want them, and rebars around opening, but also if I have stirrups defined in my in cap, which I have here, they have to be inserted 200 millimeters with a distance of 200 millimeters. So here it is, and we can see in here the spacing is 200. So this is how easy you can connect a geometry with a stirrup and then apply everything with the reinforcement template. Very, very powerful tool. So this was the in-cap and reinforcement. You can use it in many cases, and yeah, if you end up, just consult with us. I think we can help you out. But we've seen people use it in many ways, so I think it's pretty interesting and very powerful tool when you do the reinforcement here. But what I want to demonstrate now is the bended mesh. This one that we talked in the start, it's the bended mesh. So how do you make a mesh out of a rebar? We have a functionality for that. It's in the reinforcement folding menu, and it's called Draw Bended Mesh. So the first thing you do is to activate the functionality, and you need to take the wall. I'm going to take this sandwich wall, and I'm going to use the 3D because I think it's more easy to understand, more visual. You need to select the bar mark, and if you don't have already one, you can create it on your own. Let's take a look at this one. It's an N-shape code, and it's 1000 by 90. I think it fits in my load bearing panel, so I'm going to use this one. And I need to choose the mesh, and I'm gonna take now it's I'm gonna take this one now, right? And you can save it with a name. It says it's not found, but first I need to add a length. First we need to think the wall is 3000. 39. I think I'll add some length. Okay, but once I have the length, what I can do is I can either draw it or I can place it. But let me see where we can place. We can place it here. Okay. And here are some insertion tools. I think I need to rotate it, and I need to move it. First you select the insertion point, and then you move according to it. So I need to go on a top view to find out if I'm doing correct what I'm doing. Here it is. So probably we want to move it a little bit like this. Yeah. So I'm gonna try. I'm gonna say apply. And what impact says here is we added a green text because sometimes if you don't have the reinforcement uh, settings, visibility settings on, you might think, oh, did something happen or what? So if you get the green text, it happened. I just have to switch on the visibility, but I have it on. Um, so I say okay, and here it is. I have a bended mesh made out of a rebar. It's the N shape code. So if you go and try it, I want to say that there is um, you need to activate the shape codes that you're going to use for this command. So it's a little bit technical, but in standard admin, Impact Standard Admin tool, you need to add the shape codes that you need in a variable. Everything is documented in our Impact wiki, so if you intend to use this draw bended mesh functionality, it's quite easy. I want to mention also that there is an edit command, like any other command. Once you draw something in Impact, you usually have the edit command. So what you can do is, yeah, draw draw another shape or edit the length. Can we do that? Yeah, it gets shorter in here. Um, so something new here, relatively new. So I think it's a very useful tool. We hear people are very excited about it. Impact users are very excited about it. I can also mention that there's coming. We are further developing on it. What you can expect is that soon we're going to also to introduce farmers in Impact Revit. So something to be looking forward in our next webinars. I know people doing reinforcement and especially exporting to machines making a reinforcement export are going to be happy about this news. So keep up with Impact Revit and the news that we're going out with every quarter. Okay, good. That was the bended mesh. We need to continue drawing on, and what I want to do now is I want to draw a sandwich wall above because there is another powerful tool to join walls together and actually draw these casting materials I want to demonstrate. Let's keep moving. We're going to level 2. Where it is, it's here, level 2, right? And I need the 3D here so I can see if I'm doing things correct. Yeah. Okay, I'm on level 2 in on the left side, and I'm going to draw another sandwich wall. It's the draw wall command, and here I'm going to say just okay. It's my labels are 3000 high, so it must be 3000 I'm doing. Okay, I must draw on top of it. Let's see. If I go from top to bottom, I'm going here. Yes, good. We need to split the wall, and here it is, right? If I do like this, I am going to split the wall, and afterwards I'm going to draw in these walls with the help of joints. That's the tool I want to show you. So first, split the wall, must be vertically. Select the wall, it must be the one in here. Okay, and the reference plane is this one. And intentionally, I'm not adding any gap, and I'm not adding any in gap. I just want to split it. You can also do this, okay? I have two walls in here. So instead of um instead of applying in cap and then casting material templates like we did, that's one option, and that's okay to do it like this. But there's even more powerful tool for detailing, and that's the joint. So basically, what joints are doing is that you have, um, let's take a look at this one. What you're having in a joint is in cap, it will say end geometry, spacing between the walls, gaps, and inserting of casting materials in one. So if I go now and say, I'm going to say connect wall, that's where we're using the joints. Impact says select the walls, it must be those ones. I can go to my project and choose this particular join, and here I can just see here how I want to place the casting material. So first we get the information about what we're doing, right? We are which in cap and casting material we're using, but then also how to place the casting material. So I'm going to set up two where we're going to do it with the same logic like the one below. We have 200 from top and bottom and 400 in between, and the insertion point of the joint. And it's some Revit warnings here, good to have them. What it's saying is that there is, because the loops are one on top of each other, one against each other, there is um, some collisions, but that's okay because it's it's um, they're very flexible, and I think it's okay. Okay, so let's see in the 3D what we've done here. Go on wireframe. You can see we have the same result as the one below. So the first one, we have added an in cap and we used the casting material templates. The second one on top, another way, another tool in Impact, that's using the join. Both of them are great to use. It's up to you what you would like um, to use in your, I would say, particular situation that you're in. Okay, what we're doing now is we're going to do some solid walls, panel thickenings, and slabs on top. So let's get moving. I'm going to do some solid walls, and in order to do a solid wall, you need to use again the draw wall command. And I'm going to say draw wall and use the wall. I have a definition for that. No gap intentionally again. And let me see here. We are actually on level 2. That's not so good because, of course, we want to start with level 1. So let me just go on the right level and say draw wall, right? The height must be 3000. That's the level. Yeah. Yeah, center line. I think it's okay if we do it like this. We're gonna do one solid wall. Yeah, looks okay. And another one. You know, when we have solid walls, you don't have inner and outer panels, so it's really up to you how you are going to use it. And here I'm going to demonstrate again how easily you can do joints. The first thing you need to do is to split the walls. You can either draw two or split afterwards. I'm going to split this one vertically with the help of split wall command. Uh, no gap now because I'm gonna do the gap with the joint. So what I can do is select those walls and go to connect wall. and impact is automatically scanning in my database. Do I have something for this 12, I would call 20 centimeters of walls? Yes, I have. I have this joint. I can use this, but if I go out and just scan again, connect wall, I have another one also, and I think this one looks better, right? So it's the casting material as inside the wall, and it's just another way of joining those three walls. Again, you can see how the placing looks like. I'll say I want this one where I have 500 millimeters from top and bottom, and two casting materials. Okay, let's see how it looks. So automatically, there are some uh, warnings that we've added to a user, um, but I think that you can see here in the 3D views. Yeah, I think if I go on wireframe, we can also take a look at, yeah, I have the casting materials added also, as I said in my joint. So very powerful tool, the joints. I can also see if I have something for here. So joints, it's can be used not only for solid walls or sandwich walls. It can also be like this where you mix it, right? So in this case, you can see my wall is joining uh, the sandwich walls. I need some space, so I'm just going to choose this one where I need to see here how do we add the casting materials. If you go to placing, I have two casting materials, 500 from top and bottom. Okay, but take a look now also what Impact is doing is adding the geometry in the end and some gap there between the walls. Changes to some families, and Impact is informing us for that. Okay, very, very easy modeling of this joining. You have thousands of them in this project. So this as a residential project. So it's a very, very good to use the joints and save them and reuse them also. You can reuse them in upcoming projects. Your colleagues can do that as well. Okay. What we need to do now is add some panel thickening and slabs. So let me go to shaded. Yeah, I want to add some panel thickening here. And to do that, I guess I can do that in the 3D view. The panel thickening is used in many situations when we talk about precast, but I want to do it now for supporting, to draw it now for supporting the slab. So if you go to the wall falling menu, you can say panel thickening, select the wall, and here you can see that you can either select one or two. I would like to, let me see, if I go to panel thickening and here. So you can say in a panel inside, in a panel outside, or um, adding on the outer panel. So I'm just gonna say that this one is going to, the height of the panel thickening is going to be 300. The depth 200, I think it's okay. And the length, it's the length of the wall without the um, this part where we have the collision with the solid wall. Now we also need to add, you always have the lower left corner as insertion point. So you can have this uh, on x-axis, you can move it from left to right, but you can also add the height of it, which is the height of the wall without 300 must be, if you need to go to the top, must be 2700, right? So that's one of the panel thickenings in here. And we need the other one as well. Um, so you can see here, we can actually measure it on the plan. If we go to it, yes. So you need to add the panel thickening for, you can see it probably in here, for the other part, and that is going to be panel thickening. You select the wall, and I'm going to add again inner panel outside, 2700. The length must be yes, and the height 300 and the depth 200. So let's try this one. So we have the panel thickening also here on this side. If you think, let's see. Now, I want to show you a rebar functionality together with the panel thickening. And what you can say about the panel thickening is that it's one of the many components where you can add the rebar templates. So first of all, the rebar templates are something I demonstrated last time in connection with the columns and beams. So each one of these rebars, they are actually added with the help of the template. So you save the combination of these rebars in a template, and you can just apply it to the same family. The same you can do with the panel thickening. What you need to do is if you go here, I can probably select the panel. I can say apply rebar template, right? And you see we have, you can apply it to walls, to beams, columns, corbels. That was showed last time, but you can also see panel thickenings, right? So if I say panel thickenings and I select those two of them and I say finish, what I'm actually doing is that I'm applying some rebars, as you can see here, to this two rebars. Probably if I just um, make it more transparent, you can get an idea of what I'm talking about. Yes. So with the help of the templates, once you draw such rebars on a panel thickening, you can go and reuse it. It just needs to be the same family, not the same type, but the same family. You can have several types within the family, and we're gonna just adjust it according to the constraints. So rebar templates, very powerful tool. With just several clicks, you can see we can go and just add the um, the rebars, right? So I can see here we can go now and add the slabs, and the time is going fast, so let me just go on the slabs, and I guess some of you also want to see how to do it. And in order to draw the slabs, I'll be on pen on level 2, and I'm going to see here the 3D. as you can guess, we've done the panel thickenings because we want to lay down our slabs on the panel thickenings and on the massive wall and here. So I'm going to draw now the polyline. Okay, that's an AutoCAD language, but in it's the model line. Sorry, it's the model line. And I want you to pay attention that I'm actually going to draw the model line on the edge of the wall here. So it's not um, how the they're gonna span from left to right, right? And I want them to lay down on the wall and on the panel thickening. But I'm just going to go and make the polyline, the model line on the edge because I want to demonstrate this support length, which we get a lot of questions and um, comments about. So I just want to demonstrate how support length uh, um, is, how what support length is. So basically, it's just going, if you say, if how we're going to do is we say that our slabs are going to span 60 millimeters inside this hole. In order to draw slabs, you need to, yeah, have a definition and you need to go to draw slab command. Here I have it. And what you need to do is first of all select the boundary. A lot of possibilities here, but I'm gonna pick the model line. It has to be closed model line. I say finish, and here impact is already suggesting how they're going to span and showing us if there is some partial slabs. You can add them or remove them. It's doing with the thick hair. You can delete the model lines, but here it is the focus for my slab drawing. That's the support link. So here is the preview where you can see first of all the edge, right? It's color. The one that is colored is the one we are just editing right now. You can automatically add the edge geometry. So here I probably want to be this one in here. And if I go to this edge, I want to add a support length of 60. It means that the slabs are going to go further 60 millimeters inside my panel thickening and relatively the massive wall. So I'm going to do the same here. What do I have? So it's symmetrical geometry, and for the 4 I was going to add 60 and 3001. Okay, I think it looks okay, this one. You can also change the direction, add elevation offsets, add a reinforcement template or remove it. It's just up to you. Okay, so I'm gonna say okay, and my slabs are being inserted. So yeah, they are. My slabs are coming in and they look just as I wanted. If we make you can see the edge geometry here. Revit is pretty visual tool, so you can see it. You can see the edge quite clearly with what we did with the help of in caps. But if I add section like this, probably I can go and control my support plane. That was my focus. If I go to view and just measure and see, is it 60 what we get? Yeah, 60 on the panel thickening and 60 on the wall. So even though that my model line went only to the edge of the wall and to the edge of the panel thickening, if you get a 60, type in 60 for value of the support length, impact will automatically add 60 on both of the supporting edges. Okay, if we go to the rebars, I think I can add some reinforcement templates to the slab if we reinforcement templates is not only you do for walls. If you go here, um, we have them for slabs, pre-stressed slabs, all types of walls. So slab is also something we can do. A very powerful tool doing a net mesh and defining how the mesh would look like. So if I say apply reinforcement template for slab, I have one. Let's see how it looks. I can just select my slabs and say finish, and some mesh is being inserted. Same I can do for the massive walls. If I go to wall, I can see that I have some reinforcement templates. If I select my walls, can I get this one in here? Yeah, you can see I get some mesh inserted according to the template. So very, very powerful tool. Reinforcement templates is um, you almost can't go without it if you're doing with impact. What we need is some sandwich walls here. What can we do? Can we take the same one? Let's try it here. And we have some reinforcement from the sandwich walls. Time is going fast, so I think you got the idea of how powerful impact is going to be here when you're doing this during the precast process with walls and slabs. It's a repeating details, repeating insertion of casting materials or reinforcement. Save that in the impact database and reuse it in your project or projects in your company. What I'm going to do now is I'm going to save the elements. Pretty easy way for doing that is yeah, just cross selecting like this. I've been working on this part um, of the building, so I can just say save walls, and impact is just going to scan which are my walls in this selection. I have some sandwich and some massive walls, and the saving process starts. So here I want to mention that the saving process is what's in Revit technical language is converting this element to an assembly, and it's right now that we save, we give an element mark, we give an ID of this element in the impact project. It's going to the impact database. And once the element is saved, you can make a shop drawing for it, and you can preview it in the project manager. So what we're going to do now is we're going to choose our we're going to choose a sandwich wall and make a shop drawing out of it. This one probably is a good candidate. If I go to my project manager, I can update the model. I have already saved the walls. You can see it in here, right? My walls are already saved, and once in the database, it can be previewed by project manager. We missed the slabs. We missed saving the slabs. Now when we're saving, it's the same, yeah, basically the same procedure. Instead of selecting one by one, I'll do it the easy way and say save slabs. Impact the scanning, finding out which one we define as the product slab, and slabs are being saved. Once we save the slabs, they become an assembly, and we are going into the project manager. We can update the viewer, and not only we can preview the elements, but as I mentioned before, a lot of information has been given to the impact database. Like, take a look in here. For this particular sandwich wall, we can, yeah, we know a lot already. The same with the slab, right? If you click on the slab, we know the lift, the casting material, the product, and a lot of geometry information, reinforcement information. Once you save the element, you can also go and take reports out of it for the database, from the database, like reinforcement reports, right? We have some reinforcement in the elements. You can go and take it out via the project manager or report tool, the impact report tool. Last but not least, I want to demonstrate how you do a shop drawing, and we can do this with one of the sandwich wall elements. So what we're doing is that you say create shop drawing. We have a whole falling menu with a shop drawing, and this is done with the help of a shop drawing template. So I'm going to take one of the elements that we've just draw in Impact. We save it, and I'm doing shop drawing based on a predefined shop drawing template. It's a really good investment um, to work on your company impact standard, because then it pays off. In a situation like this, you define the size of the sheets, you define which views you want to have, how you want to um, dimension the components, and what you can see we're doing right now, in the lower screen here in Revit, you can see adding dimensions. So we are actually uh, identifying the components, adding dimensions, adding sheets. We have, in this particular case, we have two sheets, and we're going to the main sheet now, where in my template I've defined the geometry. So if we take the 3D in here, right, here is my element. If you remember, I talked about this in caps, that it pays off to build them, because then the geometry goes directly on the shop drawing, together with some dimensioning. You don't have to do it in hand. A preview here, I've defined a front view, section view. We can see here the panel thickening that we draw, we recognize it, and what we have here, some casting materials, information about the loops that we draw, and the information about the company and the project here. Now, I want to show you how to find the shop drawing in the model, right? Because once it's an assembly, it goes here in under the assemblies in the project browser. And here it is. This is my main that I have open now. If you open the reinforcement, what we can see is that you remember we drew this bended mesh, right? So everything that you see in the reinforcement on the main sheet, I have predefined that as a user, how and what to dimension on each particular sheet, each particular view. Shop drawing templates are very powerful tool, and yeah, I think it's yeah, a time saver, especially when you do a precast. Okay, I see that yeah, we've been passing 1 hour now, so I'll say that I, I've been through the topics that I wanted to show you today. We've done some sandwich walls, some solid walls, some slabs, and I guess that we've round out. We're going to round it up now. Take some water. And we've been here now. We've been doing this part of the building, and next time, in that will be in April, we are going to take the next three parts, the next and the last part of our spring webinars that's gonna be about foam slabs, double walls, and links. So if you are interested in this precast elements, join us in April. Sign up via our homepage or follow us on social media. If you have any questions about the webinar that you just saw today or generally about impact and impact Revit, please don't hesitate to send it to me or to our Struso support team. I would like to say thank you very much for listening. It was a pleasure for me to introduce you to the sandwich walls, solid walls, and slabs in Impact Revit. I would like to wish you a nice day, and hopefully I'll see you on the next webinar coming in April about foam slabs, double walls, and linked elements. Hello and welcome to this Impact Revit webinar. My name is Stacy Slab and I'm a part of Impact Revit team in Strusoft. I'm connecting with you from Aalborg, Denmark, and I'm going to be your host for today. This is Precast Detailing and Impact Part 3 webinar, and we have already been through modeling of beam columns and Holocaust. The picture that you see here above shows you the building that we got out of it, the structure. Then we went and built on some walls and slabs in part 2, both solid and sandwich walls. So if you're interested in this type of elements, go and see the recordings. They are on our Strusoft um, YouTube channel. Now we're going to work on double wall, foam slab, and linked elements, and we're going to do a structure on the sides of here in the building. And today, what you can expect is that we are going to solve some very, very typical challenges when doing detailing in Revit. So, how impact helps you when detailing double walls? It's the main question today, and I'm going to demonstrate you smart functionalities for solving corners, solving the priority of panels. Then when we do openings, we can see how we can automatically add these end stops around the openings as well as reinforcement. And then when we move further to the foam slabs, we're going to see some recesses that impact can do, and I'm going to show you how to also insert end stops both on edges and around the holes in your foam slab design. A typical challenge when doing double walls, that could be a detail like this. That's the T connection. We have a specially developed functionality for that. I'm going to show you how with several clicks of the mouse you can add reinforcement, recesses in both walls, as well as gap in the wall. So how to do it? We're going to test that today and show it with the impacts. And last but not least, we're going to draw linked element. In this case, I've chosen a staircase. We're going to save the elements, make shop drawings, and preview the elements in Impact Project Manager, which is the central tool when doing impact design. Now, let's get started. We're going to jump to Revit, and here is the Revit file which I'm going to build on today. In order to get the session to go a little bit more smoothly, I've already drawn some model lines that we're gonna go after when drawing the double walls. And yeah, we're gonna start with drawing double walls, and the first thing to do when drawing a double walls is going to the falling menu where we have concentrated, specially developed features, functionalities that help you do the double wall design. So the first thing you need to do is to activate the draw double wall command, and here you get your definition name, the location of the definition in your impact database, and take a notice that already here you can decide the gap between the walls. In this case, I'm gonna say 10 millimeters, and pay attention that you can decide the priority of the panels that are running on the corners. So you can preview the dynamic picture is actually previewing your settings here. If it's option 1 or option 2 you use, you can also already now add an end stop if that's something you know you're going to need, and decide the distance between left and right. But end stops is something we're doing a little bit later. Let's start with drawing the double walls, right? You can draw both in 3D or in a structural plan. I'm gonna try with the 3D now. And let's see if I say like this. Actually, I want the model line to be inside the structure, so I'm gonna go with the finish face interior stairs like this. And I'm going to draw 3 quite long double walls with the purpose of going later and using the split tool that we have in Impact. What the Impact is doing right now is taking reference in your double wall definition and adding as much components as possible, as much components as are predefined in the Impact definition. That would be lattice girders, lifts, and bracing. And Impact just came with the warning saying there is no lift defined with this mass of the wall, and that's clearly true because the walls now they are quite long. We need to split them in a while. But before doing it, I want also to draw the 3 walls here that later I'm going to use to make a T connection. So let's see if this is going to work for me. So I say 3 small double walls running by the column that I'm going to use later to demonstrate the T connection functionality. Pressing on escape, and Impact is doing the same as we saw before, inserting components in our design. So let's take a look at this. Let's see how it looks. A good thing here is to go into the parts visibility. So yeah, we have some good looking corners in here. The lattice girders are inserted. If you go on wireframe, we can see. And for these walls, we also have automatically inserted lift families according to our impact definition. Okay, we need to split the walls, and I'm going to use my reference lines in here, reference planes. I'm going to activate the split wall command, split double wall command, and I'm going to start with this long wall here. Select the wall, press on escape, and then Impact says that we need to pick the location for splitting. I don't see that Impact is working, so I guess I did something wrong, but let's try again. So what we're gonna do is first select the wall. Yes, and let's see what Impact says. You can always orientate yourself by looking here in the lower left corner. I guess you already used to that by Revit. But now I can see something is happening, and it says pick location, and I'm gonna pick those three reference lines. It actually doesn't matter if you clicked on the wall or just in here. Impact is just gonna split on the axis. On the, in this case, could be the, must be the x-axis. Okay, so now we have selected the 3 points where we want to spread. I press on escape on my keyboard, and we agreed on 10 millimeter gap. So let's see how it looks. We can follow actually what happens here on the 3D view. Impact is updating the lifts, and that's clearly because now we have walls that are way um, shorter, right? And we're gonna get lifts inserted also in our walls. You can see already here we have some um, lift families inserted, and also here. Yes, and we need to split the gable walls. It's the same procedure. Activating split double wall command, select the wall, press on um, the D in my case. That's the reference plane. I'm gonna do 2 symmetric gables. And here I'm gonna press on escape and the 6 millimeter gap. So we can follow it here. Wall is being splitted. So we're about to get yeah, some pretty good looking uh, double walls here. We need to do the gable on this side. So I'm gonna say split double wall, select the wall, and now impact is going to say that we need to select the location. I'm going to select the D reference plane, and when we press on OK, um, components will be inserted in my wall like this. And let's see what happens. We have this double walls now drawn on my project. So long so good. So long so good. We have the double walls, and you can see if we go into the wireframe sim, that is good as a red. And this there is a meaning behind it. I'm gonna explain that a little bit later why it is. It's a warning from impact. I'm gonna look at the warning a little bit later. Now we need to solve this T connection, and in order to do it, I'm gonna go into right here. I'm gonna use the 3D view. In order to solve the connection, I'm going to go to connect wall command, activate says and impact says select double walls, right? So I'm going to cross select those 2 walls in here. And here it is, the command that I talked in the start is a special command that helps you actually insert the recess on right, left side of slits. It's pretty much a lot of options, right? So I think in this case it's gonna be the left side. I'm gonna do recesses from the inside, and you can insert a hole that's in this wall. It's the hole in here that goes some distance from top or bottom, or what is new in quarter 1 is actually that this value can also be 0. if we've heard some of you want to actually make the hole from top to bottom. That's a news from quarter 1 release that it can also be 0 now. And what you can do is insert a reinforcement going all the way through the connection. And take a look at the dynamic picture again. It just shows you your settings. So in this case, I'm gonna just change the anchorage and the width. I say okay, and Impact is working now on the background. It's inserting the components that I defined, moving some lattice girders that you can see here that is standing in the way. And here how it looks, that's my connection. Let's take a look at it. If we go to shaded, uh, the lift has moved, some lattice girder has moved. Can we go to wireframe? Oh, it's not a good idea. Here, probably that's the best we can do in the 3D here. We can see the reinforcement is inserted. So yeah, uh, that's you can see several clicks of the mouse and we have all those components inserting, in including the holes to 200 millimeter from bottom and top. And remember, from Q1 release, we opened also that this hole can go all the way up. Let's do the same for the other side in here. It's basically the same procedure. You say connect wall, you cross select the two walls, pressing finish, and that must be the right side. This time I want to show the hole in the shop drawing. You see some settings go already now from the modeling to the shop drawing creation. I want reinforcement, and here I think it was 600, and what did we say here? 150. Yeah, let's try with that. Press OK, and Impact is doing the hard work for us. Adjusting the components, and here it is. We have two T connections solved in a couple of seconds. So that's great, that's awesome. We can now go further, and I think now I want to talk about the corners. If you remember from the start, here I'm gonna go to the level 1 structural plan. I'm gonna go to parts just to make it easier for you to see. I'm somewhere around here. Yeah. So if you remember in the start, we could predefine which panel goes by when modeling the panel walls in the corners, the double walls and the corners of them. But if there's changes going on in the project, you want to edit it, you have the possibility. You need to go to this switch priority of joint command, right? So you press it and you can select two panels, press and finish, and it just switches. Impact is taking the other panel, the vertical, and it goes um, by this one. And what happened is that's not only this a minor change in the geometry, but also Impact is adjusting the reinforcement for you. So if you have mesh or reinforcement and you predefine some cover, it will be adjusted by Impact. And the lattice girdle will also be adjusted. Now this one is red, right? We're gonna go to explain why this is happening in a while. But one thing at a time. We need to take the other joint, the switch priority of joint again, and we need to take the other panels. Just to demonstrate it again, we say finish, and here it's the vertical going by. So doing it one panel at a time, or you can cross select all of them and go to initial position. And Impact is not going to edit only the geometry but also all the components around. Now this one is black again. We're going to see why in a while. Yes, so defining priorities either in the draw double wall command, or later on you have possibility with switch priority of joint command. Pretty smart one, makes your design flexible and fast. Yes, okay. I think we're there where we can solve the mystery of why some lattice girders on the edges are colored in red. And this is, yeah, this is primarily because of your settings in the definition. Everything that is drawn by impact takes reference in the definition of the element. And if you go into the double wall definition, you can see that we've set some spacing for the girders, in my case 150 between, but also I've said that my girders need to be minimum 250 from the edge and maximum of 300. So that's my setting. And if by drawing the double wall and the families, this distances of 250 and 300 are um, not kept, then Impact is going to send a warning by coloring this lattice girder in red. And then it's up to you to take actions. If it's important in your design, you can go and edit the placement of the lattice girders. We're going to see how we do it right now. Or you can just leave it as it is. It's just important that you get the warning. So why this is red? Let's go to a functionality called um, edit lattice girders. It's this one in here. So you take, you press on edit lattice girders and you select the wall. Impact is going to scan the wall for you, and we're going to show a picture with the um, showing you the distances for yeah, for this double wall. So you can see this one is red in here because the distance is not kept. When drawing the element, you have a 310 millimeters instead of 300 to the edge. Now, in a lot of cases, probably say, okay, that's not much when we talk about this scale of elements. But yeah, you can take action about it, or you can just leave it as a warning. If you take this row in here, you can say, let's scan it. And this is okay because our lattice girders are 250 from the edge, so everything works fine. But you can, if you go and erase, that's one thing you can do with this functionality. You can go and erase, press on escape. Now you have this lattice girder in red, marked in red, because this is not okay according to our double wall definition. That's more than 300 as we have set up. You can move it, you can take control over it and move it along, right? Press on escape. Or you can take a new and add a new lattice girder. It's the newly added lattice girder. It's again the same family as you've defined in the definition, the same lattice girder family. So you can go and play a little bit with this one. It's a really good tool. You can go and measure and add it on precisely on this area, 250 to 300, according to in this case particular definition, or you can just leave it as it is. Now it's yeah, 5 millimeters ahead, so we say okay, we're not going that in detail. That's probably part of the tolerance. For me, it's important to show you that it's a pretty good tool that you have here. Editing the lattice girders, you can move, you can add new, and you can delete lattice girders. So go and use it in case you need to make changes with your lattice girders. Okay, and The last thing we need to do here when talk double walls is some openings. I want to demonstrate the drawing of openings in double wall. And for drawing openings in double walls, we're gonna use the customize tool. That's the draw opening in the folding menu for double wall. We strongly advise our users to use the customized functionalities as this is how to say as a reason behind. And if you see in here in the draw opening command, we have customized it so that you can draw a window or door hole, but you can just as well draw a rectangular hole and make some hole there and or a cutout. So if I start with the window opening, I'll just make it like this. You can already go now and add an end stop to your opening. So it's going to be adjusted to the geometry of your opening here. In the double wall, you can make material takeoff, edge reinforcement, uh, if you need it, and by doing it, you can add yeah, quality, and you can decide the anchorage. I think 200 is gonna be okay, and whether you're gonna cut the mesh in the element or not, right? So you can do it from here, and I'm gonna add some openings now. Some warnings here for a family. Revit comes with it, but let's see. Did I press on escape? Yeah, I think so. So I'm just gonna activate the command again. Draw opening command. Window hole, okay. It remembers my settings. Yeah, there are some warnings, but I think I'll be able to draw it anyway. So we don't use time on looking into it now. And I'm that privileged that I don't have any um, architectural or engineering plan behind. So I'm just going to place it on my facades just to demonstrate for you. The drawing out of the double wall opening, and yeah, Impact says that the weight has changed of the element. That's true. We have a recess and a now, so we need to update the lifts. And here it is. That's my openings in here. Gonna do a door, so it uh, looks a little bit better when we present the final outcome. I'm gonna do a door, and I'm gonna keep the settings. I'm just gonna make it 2 meter high, over 2 meter high. Say okay. And yeah, the insertion point is then the middle of the lower point. Can I do a door in here as well? Update. Okay, we update also the weight of those two elements as now has changed. Let's see how it looks. What we've done is that we have inserted some window and doors. Take a look in here. If I probably make it shaded. No, I don't want to save now. So we have some end stops inserted. What we set when drawing it. Can I select this? This is the end stop, and here, yeah, here it says that's the end stop family, right? And it's adjusted to the geometry. Now it's not always that you get it right. Probably this lattice girder family you need to move a little bit, but that's why you have the smart edit lattice girders functionality that would just that we just presented a couple of minutes ago. Here we have the door. Also, we have this in stops around. And do we have a reinforcement? If I go on front view, and probably I can go into wireframe. Yeah, we also have the reinforcement inserted with this 200 mm anchorage. So if you do a reinforcement and end stop, do it already in the drawer opening command. It's very smart and it's customized to double walls. The last thing I want to mention when doing this double wall part is that we have actually opened for user-defined lattice girders. If you go into this lattice girders, here is where we define components, and it say you want to make a new lattice girder. You have the possibility to say user define, and you can load your own family. Impact is almost all around the world now. We have I know there's different companies delivering components for double wall design. That's why we have chosen to open for user-defined lattice girders, and all the technical behind this development, all the technical information you can go and find in this article in Wiki. If you go into Impact Wiki and change notes, impact for Revit, and go into Q1 release, is the article where we also mention the parameters that we need in the family in order to get successful into drawing the lattice girders with the double wall and reform slab design. Okay, I think now we're ready to move into form slabs. I am going to draw some form slabs here on the top, and I'm going to add some holes, as we call recesses in form slab. So in order to draw form slabs, I think we're going to need to do it on a level 2, like this. If I move it on the left side. Okay, we can see what's going on here on the 3D view. I've already drawn some modular lines, which I hope they're gonna help me do the form slab, and I'm gonna activate the draw form slab command. So if I go into draw form slab command and I select my definition of the element, here's all the information that my definition consists. I can see that I have a mesh inside the element. I have some lattice girders and predefined spacing between. And what I need to do now is I want to select boundary. When selecting a boundary, I'm going to use the model lines that I've drawn in Revit. And here already I have the suggestion of how my form slab is going to be divided. You can always edit the insertion point by saying pick insertion. You can always have another direction if you need that. Just select direction. You can also get it in some degree, so it's it's runs diagonally here. There are pretty much a lot of possibilities for modeling. But I want to jump into edges, and here again a dynamic picture where you get some idea of how your edge, now it says straight, that's the name of the geometry I have predefined in my definition. So already in the definition, you can decide how the edge looks like. That's really smart. And you can see here how it's going to be drawn. But it's going to be supported on this beam in here and on the double wall. So I'm gonna say a 50 millimeter support length. I'm gonna say next. So here I'm also gonna need a 50 millimeter, and I'm gonna need a 50 millimeter as I have there. Okay. And what is also good to know is that you can follow for parcel slabs. In this case, I have one parcel slab which is pretty decent size of 2350. It's okay, but if it's like 8 millimeters or 10 millimeters, right, you can just say, I don't want to insert it, and you can just take it off. Okay, let's see how my form slabs are looking. If I go and say draw, Impact Revit is going to insert my form slabs for me. And yeah, let's see what we have in here. We actually have some, we call it lifting symbols, automatically inserted here on the form slab so that they can lift in the girders just on these points. This is definition defined. We define the family that we use, this lattice girder, right? And we define the spacing. What I want to show you here is the support length. If you remember, I set it to 50 so that if your boundary goes here and you say support length of 50, it's actually going to go behind the boundary 50 millimeters so that it can be supported. That's why we call it support length. So that's a pretty smart feature when modeling foam slabs. I'm gonna do the other parts. So it looks a little bit symmetric, and yeah, I need to select the boundary, and what gives me a feeling of control is when I can select predefined model lines. I'm gonna go to fix the edges. It was 50, I wanted a support length, and 50 here, and 50 here. Otherwise, I think it looks okay, and I say insert. So, pretty important is to have a solid predefined definition for the impact elements. If you have it, then the drawing is pretty time consuming. Now we have the form slabs, and what we need to do now is we need to draw some holes and recesses, and yeah, here I have some uh, some model lines that we can use. I'm going to demonstrate different ways of drawing recesses. If you go into the form slab, you can say following menu, you can say draw hole. And here you have the possibility to select if you're going to do a hole or a filling as a removing material, adding material, or you want to cut or keep the mesh. You can add an end stop already here when you draw the cutout or the hole. And you can either draw or select objects. In this case, let's try to select the model line like this and press finish and OK. Let's see what we get. You can see it here in the corner. What we expect now is to get a hole in the form slab, and not only that, but we also get the end stop in here. Yes, let's do some more holes. Basically the same settings. You can keep or cut the lattice girders, select objects. Let me select this ones. And I say, okay. Let's see how it looks. Some holes are already inserted. can see here on the right. Yes, here it is. We have the, is it better if we see it in shaded? Yeah, we have some holes that's circular. We have added um, end stop, and yeah, I think you got the idea of it. It's a really, really good tool when you go and do holes on your foam slab design. Now, as we're going further in time, I want to just demonstrate the end stop, the edge end stop. We have this functionality where you can say draw end stop and you can just pick the edges of the element. So you say if you want to have end stop on all this side, you can just pick the edges of the elements like this and say finish. You can choose the family, also offset from edge, so you can just add it like this. That's easy it is. End stops are pretty used component when you do form slab design, so it's important for me to show you this functionality. It's pretty easy. It's edge based, so you can go and do it on all edges here or just inside, also inside the elements, inside these slabs. Okay, but I think yeah, I think we should go further and do some linked elements before we save and we do the shop drawings. It's yeah, uh, pretty good functionalities here for foam slabs. Go and explore them or go on Impact Wiki. I'm sure you'll find a lot of them useful. Now, we need to jump further to the linked elements, and linked elements you're gonna find here in the Impact tab, right? And what I want to demonstrate now is, first of all, if you need to draw a linked element, let's see here, you need to have a family, of course, behind. The linked element can be everything, and when I say everything, it's literally any family. Uh, our um, our requirement is that there is a family type that has the same name as the name of the definition impact. So here we have a straight stair definition of the linked element, and then there is a family type called the same, right? Not family, but family type. And I want to draw this straight stair. It looks like this. And what I'm going to do is I'm going to say draw linked element, right? Um, I think it was in common, yeah, and I used the straight stair. Um, you can have predefined override the parameters if you want in here. That's that we open for, and we're gonna insert the staircase. Let's see. There is some, yeah, I think it's best to make a section and just set it in place. Let's see here. If I do this section here, so I can better orientate myself how to set it up to the slab. If we go to the view, can we see here? Yeah, so first of all, we need to move it, right? That we all agree on. But also, we probably need to get the height of it. In this case, Um, in this case, we can, oh, not that way, of course. We can go and set it to 4,000 or the length, but we can also change the height, 3,200. And why do I change it to that is because it's actually a pretty smart functionality for slabs. And if I go into 3D like here, I can demonstrate it. If you select a form slab, let me go to impact and say um, edit form slab, and you select this one. Um, Press and finish. You can actually say mm, show full thickness of the foam slab. Now, what we show here is the lattice girdle, but you can go and actually show the full thickness, which in this case is 200. So when this element is done, it's the 200, which is relevant. So that's why we're gonna change the height of the stair to be this 3,200. We're gonna move it down here, and probably we're gonna move it here like this. Let's see. Yeah, something like this. We've drawn the staircase, and let's see how it looks. And this is one example of a linked element, right? So I want to, yeah, just emphasize that linked elements, they can be anything. I've seen people draw dinosaur families as linked, right? It's fun, but anything, in my definition, I had some, if you go here on the link definitions, you can see I had some steel beams and the balcony, some uh, circular walls we call it. So it's a pretty open. If you can't define an element within the impact types that we've already have defined of element types, go and call it linked. Okay, but now we have one linked element here, and I think it's time to go and save our elements. What I'm going to do is first I'm going to um, save. We can save the slab elements, the form slab elements, sorry. Select them all, press escape, and now the elements are being saved in the database. Impact is going to automatically give them some element marks, and we are going to save all relevant components and reinforcement information in the database. After we save the elements, we are able to do a shop drawing, which we're going to demonstrate, and we're able to preview the elements in our center managing tool. That's the project manager when we talk about impact design. We also have this log where you can follow the saving of the elements, and impact is showing that the saving is going okay, and all the information is now saved in our impact database. Okay, we have the elements of the form slab saved. And now we go and save the double walls. We have a save double wall command, and I use the 3D as for me it's easiest to orientate. What you can also do actually is cross select. It's also easy. Probably less time taking. Go this way. Then I can do here. Select this one, and then we miss the cable walls in here. Pressing on escape, and impact is going to scan. We say save, and the saving starts. Okay, again, the same story here when we talk about double walls. We save each one of the components defined in the definition. And here's the smart part about impact, because once reinforcement, lifts, lattice girders are in the database, everything goes further to the shop drawing when we are doing that in impact. And let's see, we are now on the last double wall element, and we are soon ready to make a shop drawing. Yes, and the last element that we need to take a look at, that was the linked element. We say save linked elements. I'm sorry, save linked elements like this. Yes, press on escape, and there's one linked element that we need to save. That was the straight stair. Now, how do you make a shop drawing? Now the elements are saved, so you can actually go and make a shop drawing out of your elements. And let's take the form slab first. What you're going to do is say create shop drawings, and yeah, if you have prepared a shop drawing template, if you've worked on that and it's in your impact standard, then it's just you need to say, okay, I want to make a form slab shop drawing. You see here um, of this element, say finish, and impact is now automatically creating production drawing for you out of a predefined template. What is good to remember here is that anytime you do a change to a element, you can always resave it to the impact database and um, update the shop drawing. So it's what you get now, but if any changes get on your way to your final design, well, impact will be there to help you. So that's one example of a shop drawing, right? What we get in here, it's some views. It's up to you to decide how to organize them, how to place them up to your company standard. I would say we have some schedules, we have information about the project, some casting material schedules. This is all automatically generated by impact. So I try just to make one of the double wall. That could be interesting, I guess. If you say create shop drawing, and this one this time is the double wall. right? So yeah, let's take this one with the wall and the door. So a double wall shop drawing is being created, and once you create the shop drawing, Impact will also pop up with a suggestion to open it. Each shop drawing that is created now, it's actually a part of an assembly view. I'm gonna scroll up and down in a while in the project browser when Impact is ready and show you where to find the shop drawings in the Impact Revit. Um, it's you can see it's working on the back, and it's all the components that have been added. Are also good to mention that you have full control of how to measure and how to place your shop drawing. It's a huge list of available settings that you can do and customize. Um, so anything that you see in here in terms of dimensioning, you see the end stop here, the weighted, the reinforcement. It's up to you to decide whether it's on this view, you make another view out of it, or several sheets you can make in your shop drawing. So let's see where we are now. We are on the double wall. Here we are on double wall 05. It's called assembly, and we're looking at sheet 807. Okay, I think now we're ready to see our structure in Project Manager. If I open the Project Manager, I can update my model. And Project Manager is, as I mentioned already, the center tool of impact when doing precast design. It's not only the modeling that you can see in here, but also some precast transport planning, and uh, also planning for the transport for the casting of your elements. It's pretty smart tool. You can see all your elements are recorded. If you go and click on them, well, the information is there. A lot of parameters are saved and on place. You can, in some of the previous webinars, I've also demonstrated that you can go, and if you have activated the cast planning model, you can just go and drag your elements, and if this is your casting tables, they're just there, and you go further with your design. So here it is. We have also the stairs drawn, and it's pretty smart tool when I say the central tool in Impact. So Impact Revit has the connection with it. Go and use it. Once you've saved your elements, they are visible in the database, and it's the project manager in reality. Okay, I think that was it for today. I would like to say thank you very much for everyone that has stayed with me here to the end. It was a pleasure presenting this double wall form slab and linked element webinar. I'm pretty happy with the results that we went through, and if you have any questions for one of the three webinars we did, just don't hesitate to contact us on our social media platforms. We are here to help you with your impact design. Thank you very much for staying with me today for this webinar session, and have a nice day, everyone.